Okay, 21. It says a polynomial function has selected values of its second derivative f double prime. Warning for the test. Isaac, come on, look at me. Warning for the test. When you look at a table, I cannot recall any AP problems where you were looking at anything other than selected values. So you don't get in your head that the graph of f double prime has a certain shape. Without more information, you have no idea the shape of f double prime. All you know are 4 points. So don't give the table more credit than it has. That's it. That's all we have. F double prime. There's one other clue that is important, though, right here. Polynomial. You must have memorized that a polynomial function and all of its derivatives are continuous and differentiable. Okay, so that is helpful. So even though we only have these 4 points, we know that they have to connect in a smooth fashion. So test A, you have to run the key through first, yeah. Did it not work? It won't take it, right? It's because it's complaining because the software is running. So it's okay. Just walk around to the back of the computer. You're good. See the gray cable? Go into the computer, just unplug it. There you go, just set it down. So now it should work.
Thank you.
You're welcome. Questions so far? There we go. That was the key, right?
Mm-hmm.
Just making sure. Okay, so here we go. F is increasing. I look at Danica's chart. I cannot tell if F is increasing by looking at F double prime. That's why there's a blank here. It's telling you you don't know. So I can't answer this. I don't know. So does it have to be true? Well, my vote would be no, because I don't have any evidence that it has to be true. Same would be true for B and C for the exact same reason. You want me to explain that in more detail? So I look here and say, is F increasing? Apparently, if all I have is F double prime, I don't really know. Then I say, is F decreasing? Well, if all I have is F double prime, I don't really know. Does F have a local max? Memory. F has a local max if F goes up and then down. Which means F would have to go from increase to decrease. Still don't know. Anybody else? Cool. Let's see, the graph of F has a point of inflection at x equal 1. Okay, you must have memorized. F has a point of inflection when F changes concavity. It's on your white reference sheet. You need me to talk more about that. But we don't have F to look at. All we have to look at is F double prime. Perfect. Looking for when F changes concavity is equivalent to looking for when F double prime changes sign. That's what I'm looking for. Here's how they trick the entire world into answering it wrong and thinking they got it right. Notice the table of F double prime. Positive, 0, negative. So everyone in the world says, got it, this is true. F double prime is changing from positive to negative at x equal 1. And everyone gets it wrong for doing that. Do we understand that that seems like the right answer? Here's why it is the wrong answer. If I try to draw a picture of this, here's what I get. Let's see, 0, 5. So a point here. Uh, 1, 0. 2, negative 7, is that correct?
Yeah.
So most people just say, oh, the dots connect. Here's my graph of F double prime. It just does something like this. So that's f double prime. And look, right here is the x-axis. So f double prime is changing from positive to negative at x equal 1. Done. Trouble is we only know 3 points. We don't know everything else. So f double prime could do this. It could cross much earlier, come up and just touch, and then go down. So f double prime would be changing from positive to negative way back here, and not changing here. Hence, no inflection point on f here. I can talk about this as long as you need to make sure you understand it so you can apply it to new problems. You need me to talk more about it. That's why D has to be true. Because somewhere between x equals 0 and x equal 2, yes, the graph of f double prime will cross. It has to because f double prime is continuous, but f double prime does not have to cross here.